Hey, thank you so much, Melody, and welcome everybody in our audience to today's webcast, High Availability and Automation for Linux Virtualization, the Convirt Advantage, sponsored by Virtualization Review. I'm Chris Flack with virtualizationreview.com, and I'm here to be your host for today's webcast, so thank you all for joining. We really appreciate it. Okay, so just a few things before we begin today's presentation and get going with all the fun stuff. So just a couple quick reminders here for everybody in the audience. First things first is we are recording today's event for future viewing and listening purposes, and we'll send you a link to the email you registered with within 24 to 48 hours after today's presentation. Now, please feel free to share that link with coworkers, colleagues, friends, anybody who may be interested on today's topic. We would greatly appreciate that. Also, today's webcast will feature a Q&A session at the end of it. However, we do encourage you at any point during the presentation today, if you have a question for our speaker, please feel free to enter it via the Ask a Question box, which appears on the left-hand side of your console. And hopefully, if time permits, we'll get to everybody's questions and get out answers to everybody. If we don't get to your questions, don't feel bad. We'll make sure people from Accelerite get back to you once the webcast is over. Okay. Now, joining us for today's webcast, we have a really great presenter. His name is Arsalan Farouk. He is VP of Products at Accelerite. Arsalan is an entrepreneur, technologist, and thought leader in data center and cloud infrastructure with over 25 years of industry experience. Most recently, he was the co-founder and CEO of Convirt, which was acquired by Accelerite, where he helped establish the hybrid cloud management space. Arsalan has authored numerous articles and opinion pieces appearing in prominent publications such as TechCrunch, Read, Write, Web, etc. And he's also been host of numerous webcasts just like this one. And without any further ado, I'd like to hand the presentation over to Arsalan so he can get started. So why don't you take the floor and get underway?
Thank you, Chris, for that kind introduction, and good morning, everyone. As Chris was saying, our topic today is Linux virtualization, and more importantly, doing enterprise-grade automation with your Linux environment. So basically, if we were to look at, why we're even talking about Linux virtualization, some of you present who have already, tried KVM or even built-in Zen in Linux, you already know what some of the advantages are. And I know some of us here are considering looking at Linux and Linux virtualization and what it has to offer. And the key question they're asking is, well, is it ready for the enterprise? Can I do everything that I can do with my existing environment or the environments that I know from VMware or what have you with Linux virtualization? And the answer to that is absolutely. And not only that, but there's a significant number of benefits for open source virtualization. So, the first of all is that, if you take a hypervisor like, for example, KVM, you'll find that it is a thoroughly modern hypervisor. In fact, most of the commercial offerings predate the design and the thinking that goes into a high-performance hypervisor compared to KVM. Absolutely ready for mission-critical performance. There's a lot of very active development going on in there. And the best part of it is that not only do you lower costs, etc., but also, and something that I think is a key advantage is that there's no rip and replace. I mean, if you're running Linux, it doesn't matter what you're running. You could be running RHEL, you can be running CentOS, you could be running Debian, Ubuntu, SUSE, whatever. It's already built in. You don't have to rip anything out and redeploy your infrastructure for virtualization. So that's a huge advantage that we have when it comes to open source virtualization. With that said, a lot of people I hear talk about, well, hold on, that's all very good, but isn't it good for smaller projects and maybe smaller shops? But when it comes to enterprise-wide management, just being a super fast, super modern hypervisor is not sufficient. You need to have a very mature management tool chain around that, and that's something that the commercial vendors do very well in terms of VMware and Citrix, etc. And what about support? All of the old thoughts around if I do invest and if I do buy into the open source infrastructure, where do I get the support from? Where do I get the expertise from? Are there even management systems, or am I going to be sitting there hacking CLIs all day in order to get things to work? And of course, that's nothing inherently wrong with that, except that when you go to scale, that becomes an incredibly difficult thing to manage. So we have found that some of you are out there and they're saying, look, we see all the advantages, but it's there are these ancillary considerations that are actually keeping us from really diving in. Now, what makes it even more interesting is that if you look at VMware, which when it comes to virtualization has been the 800-pound gorilla for some time, they've done a very good job. When it comes to management, I'm not talking about just ESX or vSphere in terms of the hypervisor, because there are lots of ways in which something like KVM is actually superior in technology. But the management toolchain is fantastic, and VMware. I mean, we also have VMware customers, and they're very happy with the stuff they have. They like the vertical. It's a pretty well thought out, threshed out, good tool set, especially vCenter. vCenter is a well-loved tool, and there's a good reason for that, because it provides all of the things that people want to do with their virtualized environment on a day-to-day basis, an operations management basis. So, before we move and see whether KVM and Linux is a viable platform for us to invest in, and to build out our virtualized infrastructure on, I think it's absolutely fair to say that, look, can I get what my friends across the hall have from VMware when it comes to the sophistication and the capabilities of the management toolchain around that? So I think of that as VMware set the bar. And now we have to look at the Linux ecosystem and the open source ecosystem and see, what that looks like and whether we are meeting the bar. So, a very quick look at, and this is, far from being comprehensive, but I wanted to just get a sense of what we've got going on in the Linux ecosystem. So, some of you may have seen Red Hat's offering, which is Rev, and its open source counterpart, Overt. There's another nice, good product called Proxmox out of Europe, and then there's Convirt. The very first thing that we have to consider, when you use the word enterprise, what does that mean? It means it's not going to be living by itself. It's not going to be a little isolated silo, and it doesn't talk to anyone, doesn't require to live next to anyone. And if you want to just deploy it and manage it as a toy or a small deployment, that's one thing. But one of the things that happens in the enterprise is that we understand that Linux and Linux virtualization, whether that be KVM or open source Zen, is probably going to live right alongside other virtualized environments, other hypervisors, even cloud platforms. So one of the key asks that we have heard from our customers is that for us to actually get KVM deployed in our environment, we want to make sure that whatever the management toolchain we deploy next to it actually also has the ability to talk to and potentially manage the other stuff that we have running in the environment. And so that's something that we have, with Convirt, we have really focused on and made sure that we realize that, no virtualized environment is an island. We live amongst other hypervisors, and that's a key thing. Another thing, in order to meet the bar that we have to do, is to make sure that we are providing full service. In other words, the entire management function space, or the entire, you can say, soup to nuts lifecycle management of our workloads that exist in our virtualization area need to be managed. I mean, VMware does a good job of doing it, and that's something that is important, because our goal is to provide something that is enterprise grade and doesn't leave anything on the table to commercial tools, while bringing all of the advantages of open source, as well as cost and robustness in modern architectures. So, one of the things that I have been basically looking at is talking to a bunch of people, and one of the things that I keep hearing back is this, which is, and this is actually an actual conversation with a very large financial institution. They say, look, we absolutely see it. We want it. We want KVM. We don't want to be locked in. We don't want to pay the VMware tax. We don't want to. However, we are absolutely unwilling to take a backslide in manageability. because our processes, etc. This is the bar, blah blah blah. So this just goes back to validate that you have to provide full soup to nuts, full life cycle for KVM before you can consider this. And this we took as a goal for ourselves, and hopefully you'll see that in a demo in a few minutes. Okay, so there's one last thing that is very important, and that is something that we ran into when we were, back at Convirt and certainly at Accelerite again, which is the entire notion of, okay, so if one of the key value propositions, the reason we're considering going to Linux virtualization is to use what we have. Do you support, whatever Linux I have deployed? I've been deploying CentOS or Ubuntu or RHEL or whatever for a while, and I want to be able to just turn on KVM or, in some cases, open source and inside those and go. And do you provide this? And so one of the things that we've focused on is to make sure that you can use the Linux you already have. And one of the issues with some of the other tools is that they may be bare metal, or they may be very, very focused on one distro or something like this. But we realize that out in the world, we don't just have a single version of Linux. One of the key things about Linux is that it's a very diverse ecosystem. So we focused on making sure that not only do we do the full life cycle management. Not only do we provide enterprise-grade integration with the other hypervisor environments around us, so that we can fit well into the enterprise, but we also give you the maximum flexibility when it comes to which Linux distro you have. One of the refrains I keep hearing when I talk to customers, CIOs, as well as IT managers, which is, I want to use the Linux I have. And do you support it? And so that's a key observation, and that's something that we have focused on very much. Okay, so just wanted to set the table for this. The entire goal of this is to basically frame, why we did this, what our eventual goals are with providing the management, centralized management on automation for KVM, and then basically give you the kind of freedom you need in order to bring and onboard a project like this. Okay, so enough of that. I think let's get down to the brass tacks and show you the demo and see what the product can actually do. So let me just cut over to the demo area, and let me switch over to the other screen here.
So here we are. Here is the Convirt Enterprise Cloud primary UI. And let me just take a couple of minutes to go over what we're seeing here. There's a lot of stuff that we show here right off the bat. So here on the left-hand side, you'll see essentially we're connected to our data center. This actually is one of our demonstration environments up on the West Coast. And you'll see here in the data center that we've got a series of server pools, essentially. Here we seem to have a Hyper-V server pool. We've got some ESXi stuff going on. So Convirt is, of course, a multi-platform management tool. In addition to that, we've got some libvirt hosts out there. We've got KVM, etc., etc., etc. Here we go. This is a bunch of KVM server hosts, essentially. We call them servers in a server pool. In addition to that, we've got things like your cloud environments, which in this case we have discovered our Amazon environment, and virtual data centers. These are things that we likely won't be covering today, but just to give you a sense of the stuff that we have in the product. So when you click on the data center, actually on the right-hand side, you end up seeing just sort of a bunch of at-a-glance information about your entire data center. How many virtual machines are active, how many are stopped, etc. What density are you maintaining, VM density you're maintaining in your data center at the moment, what kind of virtualization platforms you have. We've got 7 KVM platforms, so that's what we'll be focusing on today, what your overall storage picture is. You also get a pretty nice at-a-glance information around things that should be essentially actionable. So for example, you've got high CPU utilization on some of your hosts, and that will across your entire data center prop up here, and you can take a look at it and see, okay, maybe I want to do something about that. Similarly, with virtual machines or memory usage or VM virtual. So basically what we do is we try to do here is we say, look, you've got lots of virtual machines, lots of hosts, perhaps even lots of different platforms, and we'll just promote things that you should be paying attention to, ideally to the very top. In addition to that, we've got some pretty sophisticated charting capability here. I mean, this looks a little busy because we're looking at the entire data center view. But what you can do is you can look at a lot of things. You can look at the historical metrics and behavior over various time periods, in addition to different, CPU or memory. If you want to dig a little deeper, you can actually go in and basically compare things. So, for example, you can say, my data center last 12 hours, compare the, or maybe a better example would be, take a particular server pool. You pick the server pool you want, your CPU utilization or memory, whatever metric you want to look at. Pick a period, compare that with another one, or and make some determination. So it's an entire area where you can drill in and do some analysis and diagnostics of and get a performance picture historically of how your systems are progressing. So we put all of that right here in the data center essentially dashboard. You also can take a look at a glance what your overall configuration is, what host operating systems you're running, guests, what kind of storage resources. We also have a free-form search UI where you can go in and quick searches across hosts, VMs, etc., 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 in case you want to get at something very quickly. If you've got backup schemes set up, you get a very, very quick view of how your backups are doing, where the success is, and where some failures may have occurred. We also flag VMs that are without backup. So essentially, the goal is that you have an enterprise-wide view of most of your day-to-day operational and automation tasks that we just promote right there to the very top. One other thing that's worth mentioning is down here. So Convirt is built on an asynchronous task system. So everything you do in the console, or via CLI, or via our APIs, essentially translates into a task, and you get an entire audit trail of that. Basically what, by whom, when, what was the status, and that's available for things like triaging problems or developing chargeback models and what have you. All of that is completely available here. So that's essentially the overall data center view of your virtual machine and cloud infrastructure that you have. And so with that, let's get into what we're all interested in today, which is how do I manage my KVM, my open source KVM environment. I think here, if I click here on the servers, notice how the dashboard side of the console immediately drills into an overview of just the entity you've selected here. In this case, the server pool, the KVM server pool. Well, it looks like we have 3 KVM machines here. Those are KVM hosts. Things look fairly good. So CPU, memory utilization, etc. is not too bad, which is great. So the first question is, well, how did these servers show up here? I mean, how do you do host discovery? Well, the host discovery, say for example, if we add another server to the pool, it's dead simple. Add a server. We're picking up KVM servers, so you say OK, and here we go. You just type in the name. We unfortunately don't have names. We have these IP addresses. We may, say this. Provide the credentials, and you're ready to go. I'm not going to discover one right now, but that's how you do it. Now, if you're thinking, well, hold on a second. What if I have lots of these? If I want to discover an entire environment. So this is also scriptable via CLI. So our CLI, you'll basically do a batch discover through CLI, and that'll be it. What do you need for discovery? No, it's basically agentless. So you don't need to prepare a host with, you need to deploy and run an agent to discover a host. We actually go out over standard protocols and pick up your host and discover it. So it's all, we've tried to make it very, very easy and painless to do host discovery. So, we have discovered these 3 hosts here, so let's see what we can do with it. Well, the very first thing we can do is let's talk a little bit about our provisioning scheme here. So you'll notice these are all server pools of various types of hosts, but here we have a template library. So in Convirt we have a very comprehensive template creation and template lifecycle management scheme, which is where most of us start once we have our hypervisor environment down. In our case, whatever Linux distro we're using to get KVM from. And if you look at it, it's actually a categorized template library. We've got some common templates. We've got some other platforms. We have templates against those. So let's have a look at what we have here. So in the common section, we've got some interesting templates here. We've got Linux CD install, and you can build and maintain your templates. They are versioned. You actually also get to see how many machines are using those, etc., etc., etc. So that's your template or your inventory of what kind of templates we have. So let's see what we can do. Let's do something interesting. So let's take, if I wanted to do a Linux-based CD install into the KVM environment. But let me show you something very cool here. So what we can do is I can say, well, there's a default template. I want to kind of modify that template a little bit. So what I can do is I can say, okay, let's create like. So just give me a template that is being created, create like, or is cloned from one of the existing templates. And so let's call it a webinar demo. It's rather unimaginative, but this is the webinar demo template. So what I've done is I've said, okay, so that we have a canonical Linux CD install template. We're going to customize that a little bit. So what I'm going to go is I'm going to go ahead and add a create like that Linux template, and we call that a webinar demo. So now just right here in our common templates, we have another one called webinar demo, and if you look at it, it's basically essentially cloned all the things that came out of the default template, which was Linux CD install, and you've got all the information here. So what the name, what the disk configuration is, or the virtual machine configuration parameters. So basically no work. We've just gotten one. We've got a nice little description. No virtual machines currently using that template, obviously. Okay, so, well, why did we use Linux CD install? Why did we have to do a clone of this? Well, it's because we wanted to customize it. So let's go ahead and customize it. So here we go to Edit Settings, and this is our template customization or template edit area. It's a nice little wizard type environment here. But what we're saying is, okay, so these things are pretty good, but I know for a fact that we are actually going to be building an Ubuntu CD. We're going to be using an Ubuntu CD for this. So there we go. So we've got the Ubuntu CD here. We change that. We go to the storage configuration. Turns out the template, because it was a Linux CD install that we cloned from, actually expects a CD-ROM. But we're not doing that. We have our CDs mounted on NFS. So what we can do is go ahead and edit that and say, look, I want to use an ISO file, not a actual CD-ROM for this. And let me see where my ISO file is. So the ISO file is mounted in my environment, I think. Let me make sure I get this right. I can go ahead and look at it and see it's, well, yes, NFS, very good. The ISOs, and let's see, which one did I want? We can go ahead and pick up any one of these ISOs that we have here. Let's go ahead and take this one, the Portland ISO. Okay. So now what I've just done is I'm again customizing that generic Linux CD install template and customizing it into a new template that I'm going to use for my environment. And here we are. So this is looking good. Networks, I'm not going to touch that. Here's where you actually can go ahead and figure out what your network configuration, etc. is. We have a nice default configuration, so we'll leave it there. Boot parameters, if you want to do something in terms of, and remember, this is the template. This is what's going to translate into many virtual machines. So this is a good place to reflect your environment. If you want to pass some kernel parameters, or you want to do some other type of loader, etc., this is where you're going to do that. The miscellaneous parameters, for those of you familiar with Linux virtualization, this is pretty common stuff. We also actually, at the time of templating, we can say, you know what, if I want to make this VM friendly to backup, which is something that we also do, in the future. You can actually, in the template itself, configure Quiescent scripts, etc. We're not going to do that today, but just interesting to know that it's there. Also, for the VM, if you want to configure credentials for access, you can do that here. And just basically some data-driven parameters that you can set here and override here if you'd like. We're not going to go into that, but again, just trying to demonstrate the level of configuration and configurability we have in our templating scheme to do this. But anyway, I mean, theoretically, you don't even have to touch anything, and you just say OK. And now, of course, you want to get a new version on that, and there we go. So now the webinar demo has been set up to be a good template that we can now install. So there it is. Okay, so it's in our webinar demo listing. Okay, so now what we've done is we've taken a default out-of-box template. We have gone ahead and customized that. And turn that into kind of an Ubuntu type thing that we want to use, and I guess it's time to see if all that worked. So let's go ahead and provision this template. So we say OK, provision, and here this is a common problem. Okay, so now where do I put it? Okay, I do know I want to put it in my servers area. Very good. So I'll put it here. Now what I can do here is I can go ahead and say, okay, I know the host I want to instantiate this VM from, this template from. But oftentimes you have no idea. You have a running environment and you don't know which host is has the resources, has the capacity. Where would be the right place in the server pool to put this, to instantiate this new VM. Well, what you could do is you can just punt on that. You can say, okay, let me just put it, place it intelligently in the server pool, and you don't select a host, and you just say okay. And what Convirt is now doing is it's basically starting the template instantiation process, or turning the template into a VM, and you get another provisioning dialog which looks very much like the one you had a second ago in the template. But what's happening now is you're getting a chance to configure the instance. So in this particular case, it's we can say this is webinar VM1, for example. It's the name of this thing. And what you have the option now to do is you have one more chance. All these parameters are pre-filled from the template, but you can go ahead and customize them if you like. So I'm not going to touch this. You may want to change the storage parameters, whatever you'd like, network, etc., etc. So all the parameters, and then this is now all parameters are inherited from the template, but you can now customize them just before you press go on instantiating the VM. I'm not going to mess around with this. We've seen all of this stuff. But there are couple of interesting things that have just shown up here, and I want to highlight that. Notice this VM priority. So the VM priority setting is something that you may wish to use, especially if you're going to be doing high availability and recovery, which I'll show in a little bit in this demo. And you can say, look, this is virtual machine that I'm bringing up. This is a low priority virtual machine or a high priority virtual machine. So when you're doing high availability or automation against these VMs, treat them in this way. So I'll just keep this at low. And then the other thing that we do is we say, you can schedule this. So you can say, look, instantiate this VM now, start it later. If you want to schedule a reboot, and all these things you can do now. So we can say provision it now. Of course, you can always provision it later. So start. Okay, we'll start it on provisioning. Okay, so you can of course have an explicit time where it starts. Reboot, not necessarily. Retire, if you can say, look, I want this VM to be automatically retired at a certain point. The action at retirement would be to shut it down or to delete it. So you have a very fine-grained control. And of course, notifications are integrated. So you will say, okay, if the retirement's happening, notify somebody. We allow you to say, okay, give fair warning before you retire it, especially if you're doing something like retire and delete. So there's a very fine-grained control over the lifetime of this particular virtual machine, and we basically are just going to be able to do that at instantiation time, and we press go. And now what that does is we notice that automatically in the server pool called servers here, unimaginatively. The VM has been brought up on this host, and actually we said bring it up and start it, so of course it started it. So it was provisioned and started automatically, and this host was picked based on Convirt's internal determination of where best to place it, both in terms of what the load on that host is, or how much available memory, etc., etc., etc. And so a safe place was 40.112, and that's where this thing showed up. So that's the intelligent placement and provisioning straight from the template. So very simple. Just give it a name, press it, customize if you'd like, and tell it whether you want it now, later, and how long you want it for, forever, or to obliterate it at some point. All of that stuff is pretty much very, very quick to do. Okay, so now we do have Webinar VM1 running here. Let's just click on it and see what's going on. We see things are pretty good. I mean, obviously we don't have much historical data on this here because it just got started. You are getting the virtual machine tasks. So this is the overall audit trail going on here. This is very specific to this. And so you have at a glance all the information you need. Okay, so let's just make sure that we know that this thing's actually running, and so the only way to do that is to attach to the console. So let's go ahead and attach to this thing's console. And you do that right from within here, and it looks like we're in good shape. This thing is running, and now you can just proceed. Remember, this was a CD install, so this is just going to now go ahead and we can start playing with this thing. So pretty simple. Start with a template, customize it if you'd like, otherwise just use it as is from the template library. Press a button, bring it up, and make some decisions around the lifetime of that VM, and then just start playing around with it right in here. So that's template-based VM provisioning with the appropriate amount of control wherever it is appropriate. And so hopefully you can see that when it comes to managing your KVM environment on your Linux infrastructure, you can manage in the large and automate in the large with this type of functionality. Okay, so another thing that is very cool is let's talk a little bit about the automation. So provisioning and basic lifecycle management is here, and obviously, I mean, we don't have the time for this, but what you can do to this virtual machine in terms of day-to-day operations is you can start, stop, start and view, pause, reboot, shut down, resume, create a template from this virtual machine, hibernate it, etc., 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 back it up on demand. All of that stuff that you can you generally expect is there. Okay, so now let's move a little bit on the automation side of things. So one of the things that is very popular in virtual machine infrastructures, certainly VMware and others, is vMotion, or what in the Linux world we call live migration. So let's see how we do live migration here. So for that, let's just use this U01, and what I actually have is I have a console, or sorry, a shell open to this. So let me see if I can find that shell right here. Okay, so we're in U01 here, and let me just clear this up here and do something that is somewhat continuous. Okay, so here we're getting some ping action here. So okay, so now what I'm going to do is show you live migration of a KVM host virtual machine. So let's cut back here. What I can do is I can just pick it up, drag it, and drop it. It says, you really want to do this? Yes, I want to do this. And while we're doing that, let's make sure that the machine is still alive. So now I just did a drag and drop. You'll notice in the bottom here the drag drop operation has started. The virtual machine continues to run. This is the continuous ping that's happening for the virtual machine. And the hope is that this thing is going to just drag and drop, cut over, and it looks like it just did, without any interruption in the surface, in service from the VM. So the reason I put this up is because we want to make sure that there is no visible effect and this indeed is true live migration taking place. So there it is. I mean, it's as simple as drag and drop. Live migration, pick it up, drop it into another server, and you're done. Again, back to what we're trying to do with Convirt, which is let you manage very large KVM host environments, but give you all the control that you need to be able to easily manage and do complex tasks, drag and drop and what have you. Bear in mind, all of this is also drivable using CLI and APIs. So, I mean, if you want, if you're not a UI type of a person and you're more of a sort of a cron job type person, then you can do all of this via that too. Okay, so that was live migration, drag and drop. Now let's go into something that I've talked about briefly earlier, is high availability. Now this is one of the more popular features that we have. It's very advanced automation. So I just basically clicked on the server pool, and let's have a look at high availability and what we've got going on there. So here's our high availability scheme. So before we start, let me talk a little bit about what this is, or rather what this is not. So one of the things that some of you may be asking, well, for high availability of virtual machines, why don't I just use Linux high availability? Linux has good clustering built into it. We've got Pacemaker, we've got other stuff, and there's a good HA solution out there. And sure, I mean, some people use that. The issue with that we've heard from most customers is, and from most people, is that Linux high availability is very good, but it's very heavyweight, and it also has weight not just in terms of the way it operates, etc., but also hard to configure. And once you get it configured, getting it right, and then keeping it right is a big thing. And so a lot of times people say, look, we could use that, but isn't there something lighter weight, something really out of box that we can use that it doesn't come with all of the excessive storage requirements and this and that of configuring Linux high availability? And so what we did was we built our own high availability algorithm, which is highly performant, very lightweight, and in fact does not require you to do any of that configuration of your hosts. You remember, our goal is you discover a host and all this functionality becomes available. So let me show you what that is then. So we've built our own high availability scheme, which is very performant and very low configuration. And what you can do is you can say, okay, here's my server pool, enable high availability on it, and let's have a look at what some of the choices are. So you can do virtual machine failover, which basically means, hey, if it dies, bring it up. And that's kind of simple. More interesting, at least to me, is if you have a host type event and you want to do a server failover, and in that what you look at is you can say, look, if my server dies or something horrible happens to it, what do I do? So you have multiple choices. You have the choices of declaring standby servers in sort of an n+m type topology, and you can say, here are my standby servers, and migrate these virtual machines over to the dedicated standby servers, and that's simple, right? So you just say, okay, for this server pool, use these servers as standby servers. Alternatively, what you can do is, if you don't have a lot of standby servers or don't have the capacity to have a bunch of standby servers, but you do have a low enough density that we can spread the load across your existing server pool hosts, you can select that too. Here, what you can say is, you can say, okay, something bad happens, take all the machines that were running on the host that was implicated, and move them to the peer hosts, the other hosts in the server pool, and then, of course, critically, migrate them back when the server's back and healthy. So if you set this up, now you've set up the automation, and what will end up happening is, it will behave like this. If there's an event, virtual machines will be seamlessly brought up on other hosts, whether they be dedicated standby servers or other servers in the server pools that will just absorb the excess capacity, just so as long as it's needed. And when your host comes back up and it's back in operation, automatically, without you having to worry about it, the machines will go back. And that's a very, very key feature. Okay, so for those of you familiar with high availability, you understand the importance of fencing, which basically means that if we think if Convirt thinks that a host has gone down, you want to make sure that the host is actually down. There's no room for making a mistake, because you don't want to bring up a virtual machine on a standby host or an alternate host while the original virtual machine is still up and kicking. All sorts of horrible things happen in the world when that happens. And it has, very nice little names like split brain and etc. Some cool terms, that scary terms that describe that scenario. So what we do is we say, okay, well, you could, for fencing, we have a wide support for a wide variety of devices. So in this particular environment, I do have a power strip in my environment. So what I will do is I'll say, okay, I'll use the power strip as my fencing device, and I'll configure it so that if this host basically is implicated, I can kill it dead. And the way I kill it dead, in other words, if I think that the host has become non-responsive or something, I want to make sure that dead is dead, and that means that I'm going to use my power strip to basically cut power to the host, so that we know that there are no zombie virtual machines that are running there. So these are just configuration parameters for the power strip. So we've got the thing on port 4, and then the switch is basically 1, etc. And the action is going to be no, actually the action should probably be off. Turn the host off. So when you do that, you now have configured fencing for this host, and you're saying that when high availability is taking place, or high availability based migration or event is in action, and we believe that the host is not acting well or is dead, then clobber it properly by turning it off. And when you do that, now you have high availability fencing configured for this host. So and that's how you can sort of go out and take care of all of your standby hosts and configure fencing for all of them. Remember we talked about priority at the time of provisioning the virtual machine? Well, this is where it really comes into its own, because what happens here is, imagine the case that you have a server pool that has an application running, and you may have a virtual machine with a database, and you may have a virtual machine with some middle tier, Nginx or Apache servers running, and then you may have some idling, some other sort of not very important stuff running in some other virtual machines, all in the server pool. Now, clearly, if high availability or some other event happens, you would want the critical elements to be brought up and handled with more care than the others. So what we do is you can say, okay, all my junky stuff, basically my demo VM can remain low, but for VMs, for application entities like databases, that's a high priority. That means that will be prioritized when moved out, and certainly brought up first when it's coming back. So this allows you to reconstitute your application in priority layers and allow you to bring the application back up in a sequence and control that sequence. And so this is something that we built, and you can, of course, you made a good guess at the time of instantiation, but when setting in terms of what that particular VM's priority would be, but you can of course override this here when setting up high availability. So if I set this up as critical, that means bring this back up first. If it's low, that means best effort. So that's the priority, and of course we have some advanced configurations which has to do with how much robustness do you want on the detection of down and other algorithms. So basically, the key is that high availability is very lightweight. We didn't have to go and set up Linux clustering here. We are just dealing with our basic Linux KVM environment, and the moment you discover the host by just typing in the IP address, and then that's it, you now have the full high quality, flexible, high availability available that you can configure right out of Convirt. So that's high availability with Convirt, complete with fencing. And what's one other important thing to note here is that our fencing scheme is the same as the Linux clustering. So basically, there's a tremendous amount of community and historical set of assets that have been developed against fencing, scripts, device support, various types of protocol support for these kind of things, and we can use those as is. So all of the basic Linux clustering fencing scripts are can be just plugged in here and used directly. So we do use that part of the Linux clustering piece. We just don't do all the other configuration and heavyweight stuff. Okay, so that's high availability. Now let's look at another piece of automation that some of you may find very useful, and that is this thing called dynamic workload management. So again, you've got your Linux environment, you've got your KVM servers running, and what we can do here is, for this server pool, we can set a policy around workload management. And there, for the moment, we have two policies that are available, and one is the even distribution policy. And what this does is it basically says, look, I want to level out my utilization. And what that means is basically, look, as the VMs come up, blah blah blah, load may change, profile may change. We may have some hosts in VM getting some hosts getting whacked really hard while the others are not. Make sure you continuously, intelligently redistribute the load across all of the assets, all of the servers in the server pool, so that we can get an even utilization scheme. And this is fantastic when you're trying to deal with things like spiky loads and bottlenecks in your application. Maybe one tier gets bottlenecked every once in a while, and what you want to do is you want to basically scurry off all the Apache servers to other hosts while your database is slamming the virtualization host. So this will automatically take care of that for you. And not only that, but you can, for all our workload management policies, you can specify when to run them, because you may say, look, I want to do this during my peak load power. I want to peak load time, and depending on your business and your need, it may be during the day or in the middle of the night, whatever it is. You want to say, okay, when I'm in that time period, I want the workload management to kick in, and otherwise I'm fine. I don't want any extra effort being expended trying to level out the load. So it's very flexible that way. Similarly, so that's even distribution. Now there's an alternative, which is kind of almost the opposite of this, which is sometimes, and actually oftentimes, the loads on your environment and your applications are highly seasonal or highly time-based. So typically, what happens is, say in North America, starting at midnight to 8 a.m., really there's not a hell of a lot of load. Depending on what time of systems you're in. And of course, if you're running a global business, that might not be the case. But if there's some seasonality there, that you might say, look, I want to save energy. In the middle of the night, I have this huge server pool running that is sucking up power, and the utilization is very, very, very low. So you can say, save me some power. And what that does is you basically use that power save policy for that, and you can say, look, if the utilization drops below a certain amount in the server pool, go ahead and shut some servers down. Shut them down. Move, live migrate automatically under the hood. Move the virtual machines, the workloads, onto a smaller set of servers. Get that utilization high, and and literally just go and turn the other servers off, and we can do that. And again, we can do this on a schedule. So you can say, look, do it at night. Don't do it during the day. I don't want this thing to start thrashing. So we've got both. The power save policy and the even distribution or the utilization leveling policy are both in place, and you can just set them and forget them, and Convirt will take care of it. And you also have scheduling around that. So that's workload management. You're running your KVM environment. You are looking at the kind of workloads you have, and you can actually go ahead and automate this, set and forget. And the system will take care of making sure everything's safe and nothing gets clobbered, and you get your power savings or you get your load utilization during spike time. So another very, very important and popular feature that we have for our KVM Linux customers. Okay, so that was workload management. Now let me, so that was good. That was kind of advanced stuff. Now let me tell you one of our most popular features, and I always laugh because sometimes you guys who are actually out there in the trenches running these environments, some of the features we think, we spend a lot of effort, we build complex stuff, it's great, but you get more excited by something like this. This was one of the most requested features that we put into the product, and that is here's our server, and I just want to put it in maintenance mode. Simple as that. So of course we do maintenance on servers, and what if you want to maintain, do some maintenance on a host? So you don't know what's running on it, what the impact of bringing this thing down will be, blah, blah. Don't worry about that. Just select maintenance, put it in maintenance mode, and tell Convirt what to do. So you can say, okay, I'm about to take this host down. I'm going to put this in maintenance mode. And here's what we do. Okay, well, what do you want to do? Do you just want to kill it? Or do you want to shut down all the virtual machines and bring them, and they will, by the way, automatically come back once you bring the machine back up? Or you want to not have any service continuity issues at all, and actually that's the default setting here, which is migrate them out, almost like you were doing it in HA. Migrate them out to other servers in the pool, and let me bring the server down, and when I bring the server back up, those will all come back. And so putting things into maintenance mode becomes very, very easy. This will happen safely. You will not have to worry about anything. And once you press the button, it's done. You can, of course, also select standby service to move the load to, and it will come automatically back if you'd like. Or if you want to take a server out of the pool permanently, you can just say, look, do not migrate them back, and that's it, and it's gone. So very flexible tool. And very useful, and as I said, one of the most highly requested features, and we're pleased to have rolled this out. So that's maintenance mode. Another similar feature is that, okay, so now we understand that a lot of you guys are not lone wolves. You work in organizations or you work in groups, and so let's just take the narrative forward from where we were. So say we have just put something into maintenance mode. Now I want to let all the other admins that actually have access to or deal with that my server pool or that host environment to know what's happening. So I actually can go ahead and add an annotation to that host. I can say placed in maintenance backup, or shall we say uptime is say 1200 Zulu. Okay, so now I've just placed a note. This note, if I save it, is going to go out, and it's going to stick to that server so anybody can see it, and also all of the admins that have access to this server will get this annotation automatically. And so what that allows you to do is, this is the collaborative workflow, understanding that a lot of times it's not just one person. It is a multi-admin system, so it's not just one person sitting there working on this, and you guys need to collaborate. And instead of going out of band, we allow you to basically collaborate right there from within the product. So that's maintenance mode and annotation, which is once again back to our theory of it's the single stop for your entire environment. We understand that you may have multiple platforms, but if you have the KVM platform, you need automation. We saw workload management. We saw high availability, template-based provisioning, etc., all of the administrative stuff, and then some of the collaborative management stuff around annotations and maintenance mode, etc. So that's essentially what we wanted to cover today in the demo. Now let's just switch back and recap what we have done so far.
Hey, thanks so much, Arslan, for the demo. Everybody in the audience, thanks for hanging in there and viewing it with us. We appreciate that. Okay, so now it's time for the Q&A. So if you have a question, please feel free to enter it in the Ask a Question box on your console. We've got about 5-6 minutes left here for the Q&A, so we'll try to squeeze as many questions in as we can while we finish up here. Okay, so first question here is... let's see. Arslan, when the dynamic workload policies fire, can the live migration occur immediately, or will it only fire when the policy is scheduled to fire?
Okay, so if I understand the question correctly here, I believe you're asking whether a live migration, manual live migration can happen while the dynamic workload policies are active. If that's the question, the answer is yes. You can do live migrate anytime you want. If your question's around, is there any sort of a restriction on when live migration can happen automatically, given different policies, etc.? No, there isn't. The workload policy schedule is just a window. It's just in that window, time window, is when the workload policy is active. There are no other further restrictions. So the moment the conditions are met, and remember, the conditions do have a smoothing interval on them, so there's no thrashing. So we do take care of making sure that there's no thrashing and knee-jerk reactions. The migration will take place. Hopefully that answers your question. I'm not entirely sure what you're asking, but yeah, the workload management schedule is a window, and within that window, given the smoothing parameters are met, the live migration will trigger.
Okay, got a question here. Does Convirt HA also support other hypervisors like VMware?
That's a great question. So the approach we've taken with Convirt is to basically gap fill the platforms which don't have certain capabilities. So certainly, KVM doesn't have a built-in high availability, so we provide that. For platforms like VMware, which we also do management for, operations management, you may recall that VMware showing up in the demo here, we tend to favor the native HA schemes that the underlying platforms have. And VMware, of course, vSphere has a fairly capable high availability scheme built in. So we just drive that through Convirt. The end result is that you get to essentially have a full operational control of your VMware environment. But the actual algorithm we use, or the capability we use, is the one that's built into the platform if it's available. So in the case of VMware, we will drive HA via the VMware HA scheme. And for platforms that don't have native HA, like KVM, like open source Zen, we use our own scheme that you just saw.
Question here from the audience. Kevin was curious, how often are updates released for your product?
Oh, the product is under very active development. So we've got teams in 2 geographies just plugging away. We have lots of ambitions for this, and in terms of the frequency, I guess we can just look at the fact that you guys just saw 3.4.6. 3.4.6 was, I think, released somewhere in the fall, I think September timeframe, and we are going to 3.4.7 within a month or so. So every few months we are revving the product up. So it's under very active development. We're adding features, fixing bugs, and setting up for the next few years of development in this area. So if your concern is is this being developed, we are absolutely at Accelerite. After the acquisition, we've even added more horsepower and commitment to releasing.
Question here: does your product support VDI pools?
Yeah, so the answer is of course yes, because we are just virtualization management. So we have customers that actually have built VDI environments using this. But the way they do that is they just take a server pool. Its functional role is VDI. They set it up, they manage it, all of the back-end stuff is taken care of, and the VDI can be delivered that way. If by VDI pool you mean something beyond that, like client brokerage or something like that for VDI, obviously we are more on the back-end, the infrastructure stuff, and for the customers that you use that, they just integrate with their favorite client brokering schemes. But even a better solution for VDI, if you wish to use Convirt to set up your VDI environment, is to look at our self-service capability that we provide on top of our base virtualization capability. I know we didn't cover that in this webinar. I think that we had a webinar some time ago that you can go and look at our self-service capabilities, because now the self-service is really a quick way for a lot of people to deliver and scope out VDI and do some of the things that traditional VDI brokers used to do. So I'll invite you to take a look at that if that's an interest area of yours.
All right, thanks. If you didn't get your question answered during today's Q&A, please feel free to still enter your question. We'll get to as many of them as we can. I'll send them over to Arsalan and the guys once the webcast is over here. But thank you all so much for attending today's webcast and sticking with us throughout the entire hour. We really appreciate that. Today's webcast, High Availability and Automation for Linux Virtualization, has been sponsored by Accelerite and brought to you by Virtualization Review and virtualizationreview.com. Thank you all for joining, and we hope you have a great day. Take care, everybody.